Okay, so we just left off here. I didn't want to get cut off, so I just started a new video. But to finish this, okay, when you integrate a constant, I just said that constant gets the variable of integration. But you always finish an integration that we call indefinite, with indefinite bounds. There's no sort of guidance of where I should stop with a plus c. So you would just have yet another c. Okay, so let's move on to some practice problems. Here, find the antiderivative of s of t. So I'm here, s of t, and I want to move up my function q, which is capital S of t. So when I do this, what did I say? We're going to, the antiderivative is doing the opposite. We're going to add 1 to the exponent. So if I have s of t is equal to 4t, right now the exponent's 1. So when I add 1 to the exponent, that now becomes 4t squared. And then you have to divide the entire term by the new exponent. Well, the new exponent's 2. So then when I clean that up, capital S of t is 4 divided by 2 is 2t squared. But don't forget, you always finish by saying plus c. So let's just go back and just make some connections here. If I'm trying to integrate, I know I'm going to be going up a degree. This is a linear function, so I'm not surprised that I end up with a quadratic function. Graphically, what you're looking at is I have a quadratic function of 2t squared plus c. So here is an example of 2t squared when c is 0. If I had c to be 1, I then go ahead and I have this quadratic function. It's just shifted up by 1. So if you continue, just imagine cloning all these parabolas and just going all the way up this y, and also going down, because that c could be negative. We don't know. Even if it says plus c, it could still be a negative. So what you're getting, this idea is that this is what we call a general solution. All right, and this is going to make sense to you more on our next lesson when we learn about a particular solution, and we're going to be given some sort of condition where I narrow it down to just one of these parabolas. But when I don't have any conditions, I'm just saying it's an indefinite integral, just, hey, I want you to integrate this and there's no other condition given to you, you're always going to end with that plus c. And you know from Algebra 2 that a constant is just moving up and down that y-axis. Okay, let's try the next one. So here I ask you to integrate, and I'm giving you dy dx. So now we're more familiar that dy dx is my derivative, and the original function would be y. And then if I went down that function q, it'd be the second derivative with respect to x twice. But this is where we're here. We're going up that function q, so I'm going to integrate. Okay, so when I do that, what I'm really doing is I'm going to just go ahead, and this is kind of advanced math for some of you guys. You'll see that next year you learn this towards the end of the year. When we apply an integral sign, I know I need to integrate. Well, just so you understand why we have always a dx, there's no way to integrate with two variables at the same time. So what I do here is I times this by dx and gets that away, and I times it over here. So now I have the integral of dy equals 2x cubed plus 1 dx. And now this matches. The variable of integration is x, and my integrand contains x. Here, my variable of integration is y, and my integrand contains a constant of 1. Well, if I have 1, that would be the same thing as having 1y to the 0 power. And if I want to integrate on this side, I'm going to add 1 to the exponent. Well, when I add 1 to the exponent, that becomes y to the first power and I divide by that new exponent, that dy turns into plus c. And I'm done integrating this side. So I just clean it up. It's y plus c equals, when I integrate here, okay, this is many terms, I'm just going to do plus 1. That becomes 2x to the 4th, divide that new term by 4, plus, this is a constant, and what did I say? When I integrate a constant, you take that constant and just apply the variable of integration. The variable of integration is x, so it's just 1x. What happens to the dx? That's going to be the reminder that that's a plus c. So when I clean this up, this is 1/2 x to the 4th plus 1x plus c. Now these are two constants. They're not necessarily the same constant. When I want to integrate, I want to get the original function. So I want y by itself. I'm going to minus this constant over. What every single kid wants to do at this point is just cancel these c's, but it's not what it is. You don't know that they're the same constant. This just becomes another type of c. So it just, you always finish it by saying plus c. You don't put minus c. And this would be what we call my general solution. Okay, let me just take a pause. All right, so now what you have in front of you are your basic integration rules. I'm just going to read them and just kind of explain them to you. We already did all of this. So here, the first one is what we call the constant rule. And I talked to you about that. If I have a constant as my integrand and I integrate it, you take note of the variable that's there. The variable of integration happens to be x. If it was dy, the variable would be y. And what you do is you just tack on that variable. So it becomes kx, and then the dx turns into plus c. And that's what we call the constant rule. All right, number 2, you're going to hear me say a lot, or Mr. Kesko next year, because we're going to not do so much U substitution this year. You're not even going to do it at all. But there's something called the constant multiple rule, which just basically says that, listen, if you have in your integrand some sort of constant that I can pull out to make your life easier, you can rewrite the original integral problem by pulling out that constant and just integrating the function with that variable out. It would usually make your life easier algebraically. So that's called the constant multiple rule. You'll hear often that if I said I want to integrate, let's say, pi x squared, well, pi is a constant. So instead of having that inside, I'm just going to take pi. I'm going to integrate x squared, and at the end, I'll apply that pi. So this would now become, if I go to integrate this, the variable of integration is dx, this would become x to the 3rd divided by 3, the dx plus c, and then I multiply this by pi. When you multiply that by pi, this becomes pi x cubed over 3, plus, guys, that's still c, because pi times c, if you distribute it, is just another constant. So that's just an idea of what we call the constant multiple rule. Okay, the third one we also did, but you probably had no idea we were doing it. If you see the integral of some polynomial, right, of many terms, you're integrating each term one at a time. Okay, so this is just saying, listen, you can separate this problem, and you wouldn't unless it became like some trig problems. You'll see next year that there's certain rules. Integration's nothing like derivatives. There's no such thing as power rule, quotient rule, product rule, chain rule. When we're dealing with integration, it's either the simple power rule, the base, what I call basic integration, or U substitution. That's it. So if you find that one of your terms have a special rule to integrate, you will be able to split up and just integrate the first term on its own and integrate the second. But what I want to kind of draw your attention to is that we went ahead and did that here. When we integrated here, we just went ahead and added the 1 divided by that, but then we integrated this term. that would have, this rule that we're looking at right now called the sum rule, is this, I could have done this, I called this dx plus, that's a x, plus 1 dx. You could have split that up, but you wouldn't, because that's silly. It's extra work for no reason. You would do that if you had a normal number here plus maybe a trig function, which you'll learn about trig integration next year. Okay, the next one is the same thing, as just the difference rule. So they're just saying, listen, if you have a polynomial with subtraction, you're integrating each term. That's fine. And then this was what we talked about, basic integration, which is what we call the simple power rule. Instead of subtracting by 1, we're adding 1 and then dividing by that new exponent. Okay, so this was your original function. And they're just saying n cannot equal -1, because then you would be dividing by a 0, which you know is not allowed. Okay, so that is it. This is all practice. I'm going to pause here. I want you to try it, and I'm going to work it through with you.